Hello everyone. Let us study about the unsaturation number or degree of unsaturation with respect to some organic compounds. If I choose a basic hydrocarbon, an alkane, the general formula for an alkane is CnH2n plus 2. So for this general formula, if at all I take C2, then this would become H2 into 2 plus 2. So this would give you C2H6. My molecule is C2H6. With respect to this molecule, I have to say whether there is unsaturation or not. If at all there is any unsaturation, to what extent, to what degree does the unsaturation exist? From our basic knowledge that a carbon will have tetravalency, it can easily form 4 bonds. So first let us put one bond between the two carbons. There are 6 hydrogens. Supposing that if I put 4 bonds for each carbon, here also I put 4 bonds. Then I'll put the hydrogens, 3 for each carbon. So I get this structure. In this structure, wherever I find only sigma bonds, all these are sigma bonds only. I don't find any pi bonds. So for a given molecule, if I don't find any pi bonds, we call such a molecule as a saturated molecule. Alkanes are saturated molecules. But on the other hand, suppose if I choose a general formula C2H2n, correction, CnH2n. Okay, so CnH2n, suppose that I take an example of C2, then it will be C2H4. When I say C2H4, I put two carbons, a minimum of one bond between the two carbons. There are 4 hydrogens. Just let me put 2 hydrogens for each carbon. Now for the carbon to satisfy tetravalency, there should be one more bond. So that will be a pi bond. Then we say that there is a sigma bond between a carbon, also there is a pi bond. Once there is a pi bond, there is unsaturation. To what extent is the unsaturation being existing in this molecule? We describe it in the degree. Is it first degree of unsaturation, second degree, third degree, and so on. So in this case, it is a first degree of unsaturation. Okay, we call it as a first degree of unsaturation, or to put it simply, we say the unsaturation number is 1. Okay, so let us take these two molecules again. This is C2H6, a totally saturated molecule. Here we have C2H4. There is some unsaturation and the degree of unsaturation is 1. First degree of unsaturation. Here there are 6 hydrogens. Here there are only 4 hydrogens. It means there is a deficiency of hydrogen which is leading to unsaturation. For this reason, the unsaturation number or degree of unsaturation is also called as index of hydrogen deficiency. Index of hydrogen deficiency, right? So either I call it as unsaturation number or degree of unsaturation, or index of hydrogen deficiency, this is one and the same. So this we call it as index of hydrogen deficiency. Unsaturation number we generally indicate it by U, or degree of unsaturation we call it as du. Let us take a few general examples, general formula, and then we'll try to understand what is the degree of unsaturation. Let us start with a general formula Cn H2n plus 2. Okay. From this, let me remove 2 hydrogens, because every time I remove even number of hydrogens would create one pi bond. If I remove 2 hydrogens, that would create a pi bond. Another 2 hydrogens, one more pi bond, and so on. So 2 hydrogens equals 1 bond. The general formula would then become Cn H2n. This is the general formula, because we have subtracted 2 hydrogens. Likewise, if I just go on subtracting 2 hydrogens from the given general formula, what is the degree of unsaturation? Let us understand. So here we can see that there is 1 degree of unsaturation, or the unsaturation number is 1. Okay. So every time I will not write U or du. Let us understand. I'll just put it in bracket. I'm just putting it in bracket. So try to understand that it is first degree of unsaturation. Let us remove 2 more hydrogens. Then this would become Cn H2n minus 2. Second degree of unsaturation. Remove 2 more hydrogens. CnH2n minus 4. So this should give you third degree of unsaturation, or the unsaturation number is 3. Remove 2 more hydrogens. This should give you Cn H2n minus 6. Okay. Likewise, we'll just write 3 or 4 more examples. Cn H2n minus 8. And every time this is 3, so this should be 4. This should be 5 degrees of unsaturation. CnH2n minus 10, right? So CnH2n minus 10, that should give you 6 degree of unsaturation. Let us just continue for one more. This should contain 7 degree of unsaturation. How does it work out? Let us understand by taking a simple example. Suppose let us begin with C8, then this would become 2n plus 2. So 8 to 16 plus 2, that would be 18. C8H18. If I take C8H18, it is a saturated molecule. If I remove 2 hydrogens, this would become C8H16. So a molecule with C8H16 should have first degree or 1 degree of unsaturation. It means there should be a double bond. So is it only a double bond or anything else? We'll try to understand. But right now it is C8H16. Remove 2 more hydrogens, it would become C8H14. C8H12. C8H10. C8H8. C8H6 and C8H4. Okay, so this is how it is proceeding. This is a sequence when I choose C8H18. Suppose if I take C7 or C6, then we will be getting different degrees of unsaturation. I'll just try to give you in the form of a table so that you will easily understand this, and you can also make a note of this table in your notes. In this table I have taken the general formula starting from CnH2n plus 2, CnH2n, and every time we are subtracting 2 hydrogens. So that would create a hydrogen deficiency index. I can write it as unsaturation number or degree of unsaturation. For CnH2n plus 2, the degree of unsaturation we have seen was 0, and later on it just increases by one number. Okay, let us enumerate this with few examples. Suppose that I take C2. I am just taking C2. Then it should be C2H2 into 2 plus 2. That should be C2H6. Okay, it has to be C2H6. With 1 degree of unsaturation, it has to be C2H4, C2H2, and so on. Okay, so we stop at C2H2 because if I remove 2 more hydrogens, it is just carbon, nothing else. If I choose C3, it has to be C3H8. Then C3H6 should have one unsaturation number, C3H4 and C3H2. Let us take C4. 4 to 8 plus 2 will be C4H10. Then C4H8, one unsaturation, C4H6, C4H4 and C4H2. Next, if I take C5, then this would become 5 to 10 plus 2, 12. So it will be C5H12, C5H10, C5H8, C5H6, C5H4, C5H2. Let us begin with C6. Then it would be 6 to 12 plus 2 will be 14, 12, 10, 8, 6, 4 and 2. So here you can see C6H6. Benzene has C6H6 formula, but every organic compound that has C6H6 formula need not be benzene, because we are aware of this double bond, or what do you call, degree of unsaturation or the unsaturation number. With the help of this, we'll try to get some different structures also. Okay, so after C6, let us just take one more example. C7, then 7 to 14 plus 2 will be 16. C7 H16. Later we just go on by decreasing 2 hydrogens. Or just a small correction. Here after 12 it is 10, so we'll just make a small correction here, right? And finally we will take C8, then it would be 8 to 16 plus 2 would be 18. Okay, so this table is applicable for simple hydrocarbons where only carbon and hydrogen has been given, but it can be extended to the presence of some heteroatoms like nitrogen, oxygen, or what you call halogens and so on. To maintain the symmetry of the table, I have just included a C9 series also. You can please note down this table. Every time it is very difficult for us to remember a particular formula, a generalized formula, and to remember the degree of unsaturation. So what we do is we will just take a simple formula so that whatever formula that has been given for us, whatever organic compound that has been given to us, we can find out the degree of unsaturation or the unsaturation number. Accordingly, we can even draw their structures. There could be more than one structure also, that depends, but we will be able to analyze what is the number of unsaturation in it. So the formula used is U, the degree of unsaturation or unsaturation number, equals T plus 1 minus here what I will be putting is here the first T represents a tetravalent. It represents number of tetravalent atoms. T represents tetravalent atoms. Here it is carbon. M represents monovalent atom. And tri represent trivalent atom. Well, we can put it in a easier way. U equals C plus 1, directly take it as carbon, minus, you can put monovalent, but the most common monovalent is hydrogen, or in the place of hydrogen you can also put directly M, monovalent. So even if I get a halogen, let it be fluorine, chlorine, bromine or iodine, I'll be including those number of halogens here, minus the trivalent atom, which is most common, is nitrogen, by 2. If I take a simple hydrocarbon, I will not be getting nitrogen there. Okay, so it will be monovalent, and which monovalent it is hydrogen. So usually this formula is also taken as C plus 1 minus hydrogen minus nitrogen by 2, where N represents trivalent atom, H represents a hydrogen or another monovalent atom. So whichever is convenient for you, you can use it. We have to put this formula to test. Okay, so before putting it to test, suppose that I got one unsaturation number. What does it mean? One unsaturation is equal to one double bond or one ring. It could be a ring also. It could be one double bond or it could be a ring. Suppose I got two unsaturations. When I get two unsaturations, what is the meaning of it? Two unsaturations means I have two double bonds, or it could be a triple bond, because in triple bond we have two pi bonds, so two unsaturations. Or it could be one ring plus one double bond. Okay, all these combinations work out. If there are three unsaturations, it means there could be three double bonds, right? So you can also work out the combinations. There could be a triple bond plus a double bond, or there could be two double bonds plus ring, or there could be one double bond plus two rings, or there could be a triple bond plus ring. So the number of permutations and combinations will be increasing as the unsaturation number also increase. Okay, three unsaturations means, is it not equal to three rings? Two unsaturations is equal to two rings, and one unsaturation is equal to one ring. So as the unsaturation number increase, the permutations and combinations also increase. Accordingly, we can predict different structures for a given organic molecule. As the number of carbons and hydrogens or the other heteroatoms increase, the possible structures also increase. Let us use this formula. C2H6. I am not putting the structure, just the formula has been given, C2H6. So what is U? U equals number of carbons plus 1 minus number of hydrogens H minus N, but there are no trivalent atoms, so directly take the hydrogens or the monovalent atoms. So 6 by 2, it is 3 minus 3, which is 0. It means there is no unsaturation. Accordingly, I can predict the structure. Let us take one more example. C2H4, it is again 2 plus 1 minus 4 by 2. The degree of unsaturation is 1. Now when I say 1, it has to be a double bond only. It can't be a ring. Ring is not possible for C2. Okay. C2H2, this is again 2 plus 1 minus 2 by 2. So it is 2. Since it is 2 carbon unit, ring is not possible. Therefore, we should have a triple bond. Even two double bonds are impossible for C2. Okay, so the only choice is triple bond. Let me take C3H4. 3 plus 1 minus 4 by 2. Unsaturation number is 2. With unsaturation number 2, 3 carbons, now we can have a ring. There is a possibility of ring. Moreover, there are 3 carbons, therefore I can go for 2 double bonds. Either I can go for a triple bond or 2 double bonds or a ring and a double bond. So different combinations are possible. Okay, let us just try to work out these combinations. Let me put 3 carbons. Okay, possibility of 2 double bonds. Then there must be 4 hydrogens to saturate, to maintain the tetravalency. Each carbon which are at the terminals would get 2 hydrogens. Truly speaking, this is not the structure of this molecule, because whenever we have 2 double bonds adjacent to one another, the molecule will not be planar, because these 2 adjacent double bonds would be perpendicular to one another. And once they are perpendicular to one another, the plane of these hydrogens and the plane of these hydrogens would also be perpendicular to one another. So it is a separate discussion. This is a very important molecule. We call it as allene, which is a common name, or we call it as a propadiene. Okay, that is a concept, different concept. Okay, so we are not going to discuss it now. Right, so this is one possibility. Let me take one more possibility. Triple bond is one more possibility. Okay, I have taken a triple bond. So to maintain tetravalency, 1 hydrogen, this is already tetravalent, then I have to take 3 hydrogens here. So this could be a possibility. Or when there are 2 degree of unsaturation with 3 carbons, I can also take it as a ring. One ring is possible. There should be a double bond also, ring and a double bond. Then later on put the hydrogens. So this should have 2 more hydrogens, right? So with C3H4 we may have 3 different structures. Let me take C4H6. So unsaturation would be 5 minus 3, it is 2. With 2 I can have 2 double bonds, 1 double bond and a ring, and a triple bond. So one possibility can we write this? 1, 2, 3, 4, 5, 6. 6 hydrogens, 2 double bonds. In the skeletal structure, I can write it like this: trans-butadiene. It could be a cis one also. Trans-butadiene is a possibility. We can also take this 3 plus 2 plus 1, 1 triple bond. Okay, or we can take a ring and a double bond. So this will be 1 hydrogen, 2, 3, 4 and 5, 6. Now let us take C6H6. So what are the various combinations that we have for C6H6? Degree of unsaturation would be 6 plus 1 minus 6 by 2. So it is 7 minus 3, which is 4. Right? So when I say 4, it could be 4 double bonds. So when I say 4 double bonds, what would be the structure? I can take 1, 2, right? And this could be 3 and this could be 4. Six hydrogens. Okay, this is one possibility. Or it could be 2 double bonds and a triple bond. So I take 2 double bond and a triple bond. Okay, so this can be redrawn like this. Both are one and the same. Here there should not be a confusion that this carbon is an sp carbon, therefore it has to be linear. So in the zigzag model, if at all it is a confusion, then you can put it like this, a triple bond. Later on we can put the hydrogens 1 and 2, 3, 4, 5 and 6. These are the hydrogens. One more possibility is 3 pi bonds and a ring. Okay, so let me put a ring and then put a 3 pi bonds. Well, this is well known, benzene. Okay, I may have 2 double bonds and 2 rings. So this makes it 2 rings and 2 double bonds. Kekule structure for, we call it as a Deva structure for benzene. It could be a double bond and 3 rings. So we have seen, just a second. Okay, so this is partition is making 2 rings, a third ring, and there should be a double bond. Okay, or directly it could be 4 rings. That possibility is also there. Right, so this makes it 4 rings. 1, 2, 3 and 4 rings. So many such combinations come. Okay, and finally let us take a few examples where a heteroatom is being included. So hope by this time you got accustomed to this formula and calculation part, so we'll go little faster. Okay, let us choose an example of C2H5OH. What is the degree of unsaturation? There are 2 carbons, so 2 plus 1 minus, how many monovalent atoms are there? 5 plus 1, it is 6 by 2. So whatever may be the number of oxygens, do not include it in the formula. Unsaturation is 0. Either I can write it like this because there should not be any unsaturation, or I may write it like this. So what is the degree of unsaturation? It is again 2 plus 1 minus 4 by 2. So the degree of unsaturation is 1. There should be one double bond. I can write it like this. One double bond. Okay. This is an example which gives a simple guideline saying that the double bond need not be between the two carbons, but within the molecule there should be a double bond. A double bond should exist. Okay, or unsaturation should exist. Let that unsaturation be between carbon and a heteroatom, or it could be between a carbon and a carbon. Okay, it is allowed. C2H4O2, unsaturation is number of carbons plus 1 minus number of monovalent atoms or hydrogens by 2. So the degree of unsaturation is 1. I can take this structure. 1 degree of unsaturation. This is one possibility. Later let us choose C5H5N. N is a trivalent atom. Now the formula to be used, the calculation to be done is to be done carefully. Here it is number of carbons plus 1 minus number of hydrogens minus the number of trivalent atoms. Here it is 1 nitrogen by 2. So the degree of unsaturation has become 4. When it is 4, this is 1, I can take it as a ring, and later I can include a nitrogen here. So that gives C5H5N. It is pyridine. Please try to work out this molecule. Take some time, pause the video, and then try to work out the degree of unsaturation. How much is it? 7 minus 3, which is 4. So you can go with the simplest of the molecule. You can have plenty of other structures also. I am taking the simplest. We can work out for the other combinations. This is aniline. This is pyridine. Okay. And just we'll end up with one final example, C7H6O. 7 plus 1, this one be also, this is a simpler one. Because it is only oxygen, you did not include. Okay, so the degree of unsaturation would become 8 minus 3, which gives you 5. Let us go for the simplest of the molecule. You may have various other combinations. So I got one ring plus 3 double bonds. Altogether degree of unsaturation is 4. We have to include one more. Also we have to include one more carbon. So let us include a carbon here. Degree of unsaturation, let us put an oxygen and a hydrogen. Let us count the hydrogens: 1, 2, 3, 4, 5, 6. So the best formula, C7H6O, the best structure could be a benzaldehyde. Okay, so this is how you have to work out the degree of unsaturation. Accordingly, you can predict the number of double bonds, or it could be triple bond, or it could be number of rings. Right? Now let's meet in the next video.